Now, let's move to incidence rate, which we will talk about briefly, but later on in the exercises, we will focus on incidence proportion. Okay, so what is incidence rate? Sometimes not all people are observed within the same time period. When people at risk are observed for different periods of time, we need to measure incidence rate, or technically we call it incidence density rate. Now, I want to point out something. In some references, incidence rate and incidence proportion are used interchangeably. But for this module, for this course, let's follow the USCDC definition, where incidence proportion is used for fixed cohorts, or meaning that for groups of people where they are observed at the same period of time. Whereas when we talk about incidence rates, we talk about groups of people where they are observed across different periods of time, and therefore the denominator is what we call person time. Okay. So why is it? What's the use of incidence rate? So, for example, in our schools, we wanted to calculate the incidence of dengue infection in a school from school years 2017 to 2019. Now, some teachers and some students may have been in that school in 2018 only, right? So, well, some may have been there the entire time, 2017 to 2019, but some may have been in school for only for the years 2018 and 2019 only. So therefore, the number of units of time for each person is not the same. So it would be misleading to use the total number of persons as the denominator, because the observation times are not the same. So the incidence rate, or density rate, or per person time, is computed as number of new cases of a disease occurring in a population during a specified period of time divided by the sum of total time each person was observed. So when this happens, our denominator is no longer the at-risk or number of people. It would be person time, and in this case, person years. So when the denominator is in person time, incidence is now more accurately termed as incidence density rate. Now, here's the concept of a person time. So say, for example, you have student number 1 who was in school from 2017 to 2019. So therefore, this student was observed for 2 years. Whereas you have some, let's say, students who was only in school for half a year, 1 semester, then that's only 0.5 years, right? And then you have student number 3 who was there from 2017 to 2018, so that's just 1 year. No, student number 4, half year. Student number 5, 2018 to 2019, 1 year. So these are the person years. Then you sum it up. Those with the X is the students who had dengue. Okay, there. So what is the let's see. So then you can tabulate it like this. There are the years at risk and whether they had the disease at that point. So the number of cases was 4 out of, so it's 4, but the sum or total sum of total years each person was observed was 5. So that is the incidence density rate is actually 4 cases out of 5 person years. So 0.8 cases per person year, or if you times 10, round it off. So 8 cases per 10 person years. So that's how you, if you wanted to express it as per person time or incidence rate. Okay, so attack rate. In outbreak settings, public health epidemiologists may report incidence as attack rates and further measure secondary attack rates, which some of you may be familiar with in this pandemic. So an attack rate is computed as the total number of new cases divided by the total population, which is the same as the incidence proportion. It's actually the same. It's a synonym, but it's just that it's also commonly used. So I wanted to highlight. However, you can note that the attack rate is not really a rate, right? Because it doesn't use person time as the denominator. It is actually proportion. So it is a proportion rather than a rate because its denominator is not in person time units. And the common use of this is for food poisoning. So, and we call it a food specific attack rate. So a food specific attack rate is the number of persons who ate a specified food and became ill divided by the total number of persons who ate that food. So for example, if we have 10 out of 50 school children who ate old spaghetti, who then developed diarrhea, then we say that the food specific attack rate is 10 over 50 or 20%, right? And then secondary attack rates will be discussed in succeeding modules. Now, what is prevalence? So prevalence is the proportion of the target population affected by a particular disease at a specific time. And when we say affected, it can either be new, current, and or previous cases, and not just new cases, unlike for incidence. But how is it computed? Prevalence is a proportion only. Okay, so prevalence is the number of affected persons present in the population at a specific time divided by the number of persons in the population at that time. Okay, so that's numerator, the number of cases, new or pre-existing cases of that disease, and then denominator is the total number of persons present during that time. So there, so the prevalence formula, and if you times 100, so it's then a percent. Now, there are two types of prevalence frequently reported, and that is point prevalence and period prevalence. So point prevalence refers to prevalence of the disease at a certain point in time, while period prevalence refers to a specific time period. So for example, we wanted to know the prevalence of cough and colds or proportion of school staff who had cough and colds. If you ask, do you currently have cough and colds? Then you're asking point prevalence. But if you say something like, have you had cough and colds in the past 14 days? Then you are referring to a period prevalence. It could be that they don't have cough and colds right now, but maybe they had it last week. So that is a 14-day period prevalence that you are asking for. Okay, so that's for prevalence. Now, prevalence and incidence are related. Okay, so what is the relationship? So, well, assuming what we call steady state, wherein the population is constant in size and composition, and the incidence rates and disease duration are fixed, prevalence is approximately equal to incidence times duration of disease. What does this mean? It means that the prevalence of a disease increases when there are more new cases and that disease takes longer. Okay, so that's the relationship of prevalence and incidence. So let's bring it all together and let's start computing. So you will see this in your exercises, but I will have a first example, right? So for example, we have grade 2 students of Bagumbayan Elementary School. So you have, these are the sections. These are the number of students per section. And then from January 1, 2023 to December 31, 2023, for example, you had students who had cough and colds. You had students who had a viral exanthem or, fever and rash, which is quite common in kids. And then students with diarrhea. So, for example, you have this tabulation. And you want to know, so how common is cough and colds, or to be formal, right? What is the prevalence of cough and colds among grade 2 students in the year 2023? So step 1 is to determine the numerator, which is the number of cases with cough and colds. Step 2 is to determine the denominator, which is the at-risk population, or the total number of grade 2 students. Step 3, then you divide the numerator by the denominator because it is a fraction. And then step 4, convert the decimal fraction result by multiplying it by 100 to get the prevalence in percentage form. So that's step 1, 2, 3, and 4, right? It's actually a basic fraction. So let's see. So step 1, the numerator is the number of grade 2 students with cough and colds, which is 11. Step 2 is that the denominator is the total number of grade 2 students, which is 149. Step 3, 11 cases divided by 149 students is 0.0738. Then we convert the decimal fraction by multiplying it by 100. So we get 7.38%.